All right, so today we are going to go over your Unit 1 review. So as we are working through this, I ask that you simply write your answers down on a separate sheet of paper. So this video is going to go over your Unit 1 study guide. And that study guide is what you picked up at the door today, and it is found on page 27 in your ISN. But I'm going to ask you to write those answers down on a separate sheet of paper so that you can take that piece of paper home and that you can study it tonight. And this is again posted on YouTube, so you can always go and rewatch this video tonight to study. So number one, how does science differ from other subjects such as art and history? And the difference is that science relies on testing explanations. And so in science, you have an observation and then you develop a question, and from there you test that question. And you continue to test that question over and over until multiple people get the same results. And only then do we consider it true science. So science is different because it relies on that extensive testing of our explanations by multiple people. Number two, ask you to discuss briefly the steps of the scientific method. Remember that you begin with an observation, and from there you develop a question. After the question, you do research. The research then allows you to develop a hypothesis, and the hypothesis must identify your variables, and it also must be testable. And then you test that experiment, and during the experiment, you collect data, and that data can be either qualitative or quantitative. Then you analyze that data, and from that analysis, you draw conclusions, and then you report your findings. You can report those findings to other scientists in journals, or in reports. All right, number three, the differences between observations and inferences. Observations is that we gather that information using our five senses or scientific tools, and then inferences are logical explanations of those observations. So think back when we looked at that picture of that boy falling from the tree. Right, so we saw him sitting up in the tree, and he was in the water. We made those observations of in the water, there was a tree, there was a goat, there was a boat. But then we drew these inferences like that he fell in, or the goat pushed him in, or he's on a farm. So those inferences are explanations or conclusions we draw based on our observations. Number four, you have to be able to identify the independent and dependent variables. So you will be provided on the test with scenarios. And in those scenarios, you will have to be able to pick out the independent and dependent variables. So you know that remember that the independent variable is the test variable. It's what you as a scientist or the scientist is changing or manipulating. So if you're trying to figure out if the amount of water in plant impacts the plant growth, the amount of water is what you're changing, right? You might have 0 milliliters, then 5 milliliters, then 10 milliliters. You are changing that, you are testing that. Now, how you're measuring something is your dependent or outcome variable, is what is influenced by that independent variable. So if we go back to that thought about plants, and if you add different amounts of water and you're trying to see its impact on plant growth would be your dependent variable. Now, when you have an experiment, you normally have a control group and an experimental group. The control group is the group that doesn't get anything changed. So it doesn't even have the independent variable. The experimental group has the independent variable. So if we go back to that idea of plant growth and water, you would have a plant that's getting the normal amount of water it typically does. And that would be your control group. Now, in a control group and an experimental group, you have to keep the variables the same. So it would have to be the same plant. It would have to get water at the same time. Even though we are talking about the amount of water, it would still have to get water at the same time of day. It would also have to get the same type of water. It would have to get the same amount of sunlight. All variables have to remain constant so that you are only influencing the independent variable. Now, number 5 asks how many variables are changed in a controlled experiment. Remember, in a good experiment, only one variable is changed, and that one variable that is changed is our independent variable. And so our control group, the reason why we have a control group is that it allows us to compare the impact of that independent variable. And it is important for us to use those constant variables for in both the experimental and control group so that you're able to only test the independent variable. If you're giving a plant extra fertilizer and you're trying to see if plant growth is being impacted by water, you're now introducing fertilizer as a possible variable that's making that plant grow. So you want to make sure that you only isolate one variable so that the end outcome is only on that one variable. There's also 2 different types of data you have. You have quantitative and qualitative. So when doing an experiment, you can have both types of data. Remember, quantitative, it has the N in the word, and so that helps us know that it's based on numbers. So it's going to be measurement based. Okay, now qualitative has an L. It's what it looks like. It's our descriptive data. So quantitative would be length, height, mass. Qualitative would be like it looks dead. All right, I numbered these wrong, I think. So this is number 9. Cross that out. 9 and 10. All right, so number 9, you will have to interpret graphs. That's what we've been practicing. And you may even have to pull out the independent and dependent variables from those graphs. Remember, there's different types of graphs, such as bar graphs, which allows us to compare information, line graphs, which show change over time, circle charts or pie graphs, which allow us to show part versus whole, and a scatter plot, which really helps us to find the average. Remember the idea of dry mix, right? So dry mix, dependent on the Y, so D on the Y axis, and the manipulated independent goes on the X axis. So the independent on the X. So if you're having to determine the graph, remember the dependent variable will be on the Y and the independent will be on the X. Dry mix. All right, so we've been recently going over theory, law, and hypothesis and what the difference is. So a theory is an explanation as to why something happened, and many scientists have had to study this, come up with the same results for it to be considered truthful. Remember that theories can change as new evidence is gathered. Evidence is often gathered through new technology. So as we gather new evidence, theories can be changed, and that theories aren't just one person's idea. They have been extensively tested. A law is simple and absolute, and it's what happens under certain conditions, and it's often written as a mathematical equation. So it tells us what happens every time this situation is the same, right? So like I said, the law of gravity, if I keep dropping a piece of paper, it's going to be simple in the fact that that piece of paper is going to fall to the ground. And then a hypothesis, remember, a hypothesis is testable prediction, and it's tested by a single experiment by a single scientist. So it's done one time by a single scientist, and it is being able to be tested. Now, if multiple people come up and are able to get the same result of a hypothesis, that hypothesis can lead to a theory. All right, so number 11, we've been going over this as well, repetition versus replication. Remember, repetition is when you as a scientist copies the experiment over and over again. It's when you're conducting multiple trials. Replication is when someone else copies it over and over. Repetition allows for you to make sure that information is correct. And replication is when someone else copies it over and over to also make sure it's correct. So number 12, both of these are important for accuracy and precision. And because of that, we must keep detailed procedures. Repetition, multiple trials. Replication, someone else tests it. If someone else is getting the same results as your multiple trials, then we can prove that that is accurate. So just a few more notes on this information. So tomorrow you will have a test. It's about 25 questions long. Okay, so in those 25 questions, you need to make sure that you read the information. You can rewatch this video over and over. It is public on YouTube, so you could just search Miss Tate Unit 1 test, and you can rewatch this over and over. Also today at the door, you picked up a QR code. That QR code you can scan, and it will take you to the test. I mean, it will take you to the virtual tutoring tonight. So there's virtual tutoring night at 7:30. I'll be going over more information related to test. So if you have any questions, you can come in. If you come to 3 virtual tutorings in a year, you get a free 100 on a study island. And that doesn't mean after 3, you don't keep banking, right? So if you come to 3 and then you come to another 3 and then another 3, that would be a total of 3 study islands. They're held every other week, and we're just starting this Monday before the test. If you have any questions, email me. I am on campus today. Please behave. Now that you're done with this, you can work on your notebook.